Hello everyone, Namaste. Welcome to this online session. Today is April 22nd and we celebrate this day as our Earth Day. We started celebrating this day 50 years ago and was started as an environmental movement in the United States. And that movement also led to the formation of the famous Environmental Protection Agency of the United States. Later, many other governments also started the ministries and agencies for protection of earth, environment, and climate. We have also two ministries, related ministries, MOES and MOEFCC. So why do we want to celebrate this day? In fact, there are many commemorative days in a year. For example, Environment Day, Oceans Day, Meteorological Day, Maritime Day, and Ozone Day. Yesterday it was Civil Services Day, today is the Earth Day, and tomorrow it is Book and Copyright Day. So as compared to other commemorative days, this day is very important as it is the Earth Day because the Earth gives us air, water, food, shelter, and everything on the Earth. Therefore, this day also reminds us our responsibility to protect the earth for our own existence and for our future generations. This is particularly significant in the current situation as we are facing one of the worst hit pandemic situation in the world, the COVID-19. So this day also reminds us what we have got from the earth and what we have done to the earth. So the theme of this year's Earth Day is the climate action, inspired from the Paris Climate Summit. And as we are celebrating the 50th anniversary of this commemorative day, it is also the right time to examine what happened in the past 15 years in terms of climate of the Earth. So the question is there any change in the climate of the Earth over the past 50 years? The answer is yes. We have to tell this and we need to remember this. For instance, when we look at the IPCC, WMO, the State of the Climate reports, these are the reports made by scientists across the world, and Intergovernmental Panel for Climate Change, World Meteorological Organization, and the UNEP, and other international agencies that work on environmental and climate-related topics. So they are showing that there are observational evidences to prove that the surface temperature has warmed at least 0.6 degrees over the past 50 years. There are significant changes in rainfall, in particular the pattern of rainfall. We have many regions, droughts in many regions, and some regions we have frequent floods. The global sea level has increased. And in Indian Ocean, the increase is 1.7 millimeter per year. And in the past 50 years, it is increased about 8.5 centimeter. And glaciers are retreating, ice-clad regions are melting. Imagine the Greenland alone has contributed to 20 to 25% of the sea level rise in the past few decades. So we have more extreme events, such as more rainfall in short periods, which would make severe flooding. Examples are Chennai, Bangalore, Mumbai, Ahmedabad. And we had, in the last 10 years, last decade, we had many urban floods. And in Kerala, we had two consecutive 2018 and 2019 floods, which occurred after 120 years. Similar event happened 120 years ago. On top of this, we have more frequent cyclones, more powerful cyclones, and even over the Arabian Sea, we had two consecutive or simultaneous cyclones in 2019. You know the case of Maha and Kyar. It happened after 70 years. A similar event happened 70 years ago over the Arabian Sea. And regarding Arabian Sea, you know that this Arabian Sea region is less prone to cyclones and less known to cyclones. So even in that oceanic region, we had consecutive and strong, powerful cyclones. So I have to remind you that these extreme weather events, such as floods, heat waves, cyclones, are also the harbingers of climate change. Furthermore, we have unprecedented atmospheric pollution in our cities, and most of our cities are heat islands. This situation has inflicted many respiratory diseases and premature mortality. Studies have shown that the air pollution is the 5th largest killer in India after high blood pressure, indoor air pollution, tobacco smoking, and poor nutrition. We had 6.2 lakh premature deaths in 2010. This was just 1 lakh in 2000. That means in 10 years, there was an increase of 6 lakh. That means the 6-fold increase in premature mortality due to air pollution. And you know that our water bodies are polluted, including sea and oceans. And you must be also heard of the claims that now the Himalayan mountain ranges can be seen even from Jalandhar, which is 200 kilometers away from those mountain regions. That means the visibility is increased, the pollution has decreased. And many of our rivers are clean now at parts because of the current lockdown, suggesting that the anthropogenic pollution was very severe. Therefore, it's clear that our actions have negative impacts on the earth, on the climate of the earth. So how that happened? In this context, I would like to give you an example that describes a simple human action that have changed the climate of the earth, the southern hemisphere. This is nothing but the story of ozone hole. I have been working on atmospheric chemistry related to stratospheric ozone and polar ozone for the past 21 years. This is the science related to the ozone changes in an altitude region between 10 and 15 kilometers above the Earth's surface. We have ozone in the atmosphere, good ozone, in the stratosphere at about 10 and 15 kilometers, 10 to 50 kilometers. This ozone is good because it shields harmful ultraviolet radiation reaching on the surface. And that's why the life exists on the Earth. This means if there is a significant reduction in ozone, there will be a number of direct negative health effects and other environmental consequences. That's why we are studying and we are closely monitoring these changes in atmospheric ozone. And ozone is produced effectively in the tropical latitudes, 30 degrees north and 30 degrees south, between 20 and 40 kilometers, because all these reactions are temperature dependent and wavelength dependent, UV radiation wavelength. And its production is effective at these latitude and altitude regions, and it's in balance there. However, ozone can be catalytically destroyed by reaction with chlorine, bromine, and other halogens. And one chlorine atom can destroy thousands of ozone molecules. Therefore, if there are more chlorine, more ozone loss will be there. Now, we go back to our kitchen, our house, where we have a fridge or AC that emits CFCs. You know that chlorofluorocarbons, CFCs, have chlorine in them. So that can also destroy ozone. Imagine that chlorine reacts and depletes ozone amounts in the stratosphere. But will that make an ozone hole in the Antarctic, where we have no industries, not many people, and far away from sources of chlorine or bromine compounds? Here comes the role of atmospheric circulation. It takes the trace gases and pollutants to different regions of the Earth. In the stratosphere, it takes about 5 years from tropics to the Antarctic or to the high latitude to get from tropics to the high latitudes. And for the mid-latitude, it would take 3 years. So imagine that CO2 is produced in the tropics and is transported to Antarctica. So we have chlorine in the Antarctic. Will that make an ozone hole there? No. There is a special meteorological condition for this. In winter, in Antarctic, 4 or 5 months, it will be in complete darkness and there will be no sunlight and the temperatures are very low. But the adjacent mid-latitudes have relatively higher temperature, so the temperature gradient between the mid and high latitude drives the air masses to the high latitudes. And when the air masses are transported to the high latitudes, to the Antarctic, the Coriolis force act on this, and then that will make a cyclonic circulation over the pole. And this cyclonic circulation is called polar vortex, which is very strong, nearly impermeable, and effectively separated from the nearby mid-latitude. So it just acts as a containment vessel with cooling vents, wherein temperatures are very low enough to form a special kind of cloud called polar stratospheric clouds. And these clouds are composed of chemical compounds such as nitric acid, sulfuric acid, and water vapor. It's not like the rain-bearing clouds, what we see outside here in the troposphere. So on these PSCs, polar stratospheric clouds, the chlorine and bromine reservoirs, one example is HCl, another one is chlorine nitrate, they can activate and release chlorine and bromine. And those halogens can destroy ozone in sunlight as the spring arrives. So the vortex sustains for the whole winter and spring with low temperatures and PSCs, and there will be continuous ozone loss for months in Antarctica. So due to this situation, or in this situation, the ozone loss will be massive and it will be completely lost at some altitudes, what we call ozone loss saturation. And at other altitudes or in other regions, the ozone loss will be 90 to 65%. So that means there will be large loss of ozone, continuous ozone, because of this continuous ozone loss, to make a hole-like situation. Now that the ozone hole is not a hole, it's the depression of ozone values below 220 tops unit. That means if you integrate the ozone values from surface to the top of the atmosphere, and those values are below 220 Dobson unit, then the situation is called ozone hole. And this is how an ozone hole forms over the Antarctic, or ozone hole formation in the Antarctic. So we have another polar region, Arctic, and you know that there is no ozone hole in the Arctic. We talk about the Antarctic ozone hole, but not Arctic, because the temperatures are always 10K higher in the Arctic, and the polar vortex is always disturbed because there are sudden stratospheric warmings, and there are vortexes disturbed by atmospheric waves, infrequent polar stratospheric cloud formation, and less availability of chlorine to destroy ozone. So the ozone loss is smaller in the Arctic. So if there is a ozone hole, so what? Our initial concern was the health effect, as many South American countries have skin diseases, eye diseases, and even cancers because of the high doses of UV exposure due to ozone hole. However, recently we have also observed that ozone hole changed the climate of the southern hemisphere, such as more warmer summer days in southern Africa, changed the rainfall pattern in the southern subtropics, altered the wind patterns, damaged the ecosystems in the southern oceanic regions, and that has even changed the surface circulation or currents in the southern ocean. And we have also similar results from model simulations. So in brief, the CFCs released from our kitchens or the tropics about 6,000 kilometers away from the Antarctica has fundamentally changed the climate of southern hemisphere. In addition, the change in a trace gas amount about 10 kilometers above the Earth's surface has invariably altered the climate of the Earth. So when we look back, what we did, we had only some fridges, ACs, or some industries. But this taught us this. We need to be careful whatever we do and whatever we do with the Earth and its resources. It may look harmless, but it might have far-reaching implications for climate change. If climate changes, everything will be changed. So what about the situation of ozone hole? It is recovering because the halogens are decreasing due to the ban on CFCs and ozone depleting substances imposed by Montreal Protocol. But still there is some chlorine in the stratosphere or in the atmosphere. Therefore, there would be ozone holes in the coming years also. It would take at least 30 to 40 years to completely recover the Antarctic ozone hole. we published a paper on this because the first signature of ozone recovery was there even at the saturation altitude. Now there is another interesting scenario that we never thought there would be an ozone hole in the Arctic. But this year, in this winter, we have seen that there is ozone hole over the Arctic. And this is an interesting situation because in the south, in the Antarctic, we are observing the signatures of ozone recovery. But the northern pole enters a new unimaginable oxygen situation. So it's also a climate change signal because it's the more colder the winter is, the more ozone loss will be there. So what we can do about the climate change? It may be simple things, but we have to do what we can do. Maybe turning off lights if you do not use it, use better bulbs, batteries, energy efficient systems, switch off fan, AC, TV, anything that you do not use, conserve water, plant trees and make forest, do not litter, and do not make pollution, and reduce, reuse, recycle, the 3 R's. And reduce the air pollution also because the air pollution has a climate component. Because most of the pollutants are greenhouse gases that can warm the atmosphere. So reducing pollution means there is a climate benefit. These are small things, but that can make a big difference. So let this be our climate initiative or climate action as a pledge on this day. These changes in the environment and climate warn us that although we have freedom, it doesn't mean that we have freedom for doing anything and everything. We have to use our freedom responsibly and we have to be responsible citizens. With that, thank you. Dhanyavad. Stay at home, stay safe.